is on dividing fractions. And we're going to find dividing fractions is very similar to multiplying fractions. Okay? So let's review what it means to multiply fractions. Remember what we wanted to do. Make sure our fractions were reduced as much as possible. And then multiply the tops together and multiply the bottoms together. So in this case, I'm going to look to see if I can reduce this 3 over 5. That can't be reduced. Then I'm going to look to reduce the 10 over 11. That can't be reduced. But I can also do what's called cross-canceling. Anything on the top can cancel with anything on the bottom. So 3 doesn't go into 11, but there's 5 and 10. Do they have something in common? Yeah. A 5, right? I can take a 5 out of both of them. So if I divide this out by 5, that's left with 1.
Yeah. 2. Oh, I'm just kidding.
Just divide that by 5. I end up with 2, right? So what essentially I'm doing there is taking out a greatest common factor, right? The greatest common factor is 5, and I'm dividing both of those by 5. Once I get to there, I'm left with essentially 3 over 1 times 2 over 11, and I multiply the tops together, and I multiply the bottoms together. So 3 times 2 is 6. 1 times 11 is 11. Here's one for you to try. I want you to try this one over here. I'm going to make for you. So what if we have 9/14 times 7/3? Give that one a try. See if you can reduce anything first. See if you can reduce anything first. Take a second. So this one, 9 and 14 can't cancel, but I know that 9 and 3 have a greatest common factor 3, so I divide 3 out of there and 3 out of there. 14 and 7 have a greatest common factor 7, so 7 divided by 7 is 1. 14 divided by 7 is 2.
Oh, it was 3 over 2. I got it. Big bags.
And then we multiply. We end up with 3 over 2. This is an improper fraction. This is the top is bigger than the bottom, or the numerator is bigger than the denominator. So I can write that as 2 goes into 3 one time with 1 left over. So 3 and 1/2. So going from a mixed number, or an improper fraction, to a mixed number. The last thing we need to review from the last one is, how can I deal with mixed numbers and go back and forth between a mixed number and an improper fraction? So let's say I have the number 2 and 2/3. If I want to multiply these, I need to go ahead and change these to an improper fraction. So remember how I do that. I'm going to
3 times 2 plus 2.
Multiply in that circle. So 3 times 2
Plus 2.
3 times 2 is 6.
8.
Plus 2 is 8, and we leave it as 8 over 30. Those are equivalent. And I can go backwards like I did here. Let's say I have 9/4, yeah? And I want to make that a mixed number. I'm going to take 9. How many times does 4 go into 9?
Twice.
2. And how many are left over?
1.
2 and 1/4. So I know 4 times 2 is 8, so that will come out of there, right? And then there's 1 left over, 2 and 1/4. So the key to dividing fractions is multiplying by the reciprocal. So what a reciprocal is just something flipped over, upside down, right? So the reciprocal, we're flipping it over. Huh? So the reciprocal of 3 over 7, or 3/7, is going to be 7/3. So we're going to flip that over.
How come the arrows are
The reciprocal of 2/3 or negative 2/3 is just going to be negative 3/2. All I'm doing is flipping that over. You try these last two. See if. So the reciprocal of 5/4 is just 4/5. 4/5.
I think I got
This last one's a little bit tricky. Remember, we can write any whole number as a fraction. We just put it over 1. So this is 6/1. The reciprocal, we flip it over, and we get 1/6. Easy enough. The key to dividing fractions. The key to dividing fractions. Write this on the bottom of that page. To divide fractions, we multiply by the reciprocal. Right? So whatever the first one is, the first fraction we leave alone. The second one we're going to flip over and change it to multiply. So the key to dividing fractions, multiply by the reciprocal.
How come it's rainbow with the heart?
Sorry about that. This next one. Let's consider how many half-foot pieces can you cut a 7-foot piece of wood by? So let's say we have a 7-foot piece and I want to cut them into half-foot. So how many of those would be in here? So what we can do is, let's divide this foot into this. Divide this into 2. How many of these pieces do I have now? $13, $14. So I took my 7-foot piece of wood, and I want to figure how many pieces I can, so I'm dividing it by half. So what we're looking at here is we're taking our 7-foot and dividing it by 1/2. So whenever I divide, this is what I'm doing. I'm taking this 7, I'm going to put it over 1, and then I flip over the second one. I want to multiply by the reciprocal. So times 2/1, and then we multiply our top and our bottoms. We get 14/1, which is 14 pieces. 14 pieces. Next, let's take a look at this division table. So what happens when I have 8 divided by 16, right? That's 8/16. 8/16. If I reduce that, I can divide the top and bottom by 8. I end up with 1/2. What about 8/8? Remember, division is just fractions. Division is just fractions. Right? Whenever I have a fraction, I know I'm looking at it as a division problem. And whenever I have a division problem, I can look at it as a fraction. Okay? So 8/8 is 1. 8 divided by 4. 8 divided by 2. 4. 8 divided by 1. 8. What about 8 divided by 1/2?
That's all right.
Or how many half-foot sections can I divide 8 in? So let's see. 8/1 times, or divided by 1/2. What do? We flip over this second one and multiply. So 8/1 times 2/1. 16/1, or 16. Do we notice a pattern here? Right? As we're cutting this in half, right? This side is doubling. So we go from 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 8 times 1 divided by 1/4, 32. And then 8 divided by 1/8 is 64.
Wait,
So, a short video to watch on dividing fractions. Yeah, thanks, sir.
Hi, welcome to Mathematics. This video is all about dividing fractions. But in order to understand how dividing fractions works, we first need to learn about something called reciprocals. A reciprocal is just a fancy math term for what you get when you switch the top and bottom numbers of a fraction. For example, if you have the fraction 1/2 and then switch the top and bottom numbers, you'll end up with 2/1. 2/1 is the reciprocal of 1/2, and 1/2 is the reciprocal of 2/1. And an interesting thing about reciprocals is multiplying a fraction by its own reciprocal will always give you 1. That's because you'll have the same multiplication problem on the top and bottom, so you'll end up with a whole fraction, which is always 1. Okay, that's nice. But what do reciprocals have to do with dividing fractions? Well, reciprocals let us do a really cool trick that makes dividing fractions easy. Whenever you have to divide something by a fraction, you can just multiply it by the reciprocal of that fraction instead, and you'll get the correct answer. And that's great news because multiplying fractions is so simple. This trick of multiplying by the reciprocal works because fractions are really just mini division problems. So when you multiply something by 1/2, it's the same as dividing by 2, since 2 is below the fraction's division line. And dividing by 2 is the same as dividing by 2/1, because you can turn any number into a fraction by just writing a 1 as the bottom number, right? But look, reciprocals. That's why multiplying by 1/2 is the same as dividing by 2/1. And it's true the other way around, too. So really, it's kind of like you never have to divide fractions. You can just rewrite your division problem so that you're multiplying by the reciprocal instead. Then when you multiply, you'll get the answer for the original division problem. As always, let's see a couple examples of how this works so you'll really understand. Let's try this problem. 3/4 divided by 2/7. Okay, so the first thing we want to do is rewrite our problem. Instead of dividing by 2/7, we can multiply by the reciprocal instead. The reciprocal of 2/7 is 7/2. So our problem becomes 3/4 times 7/2. Oh, I should mention a mistake that a lot of students make when they first learn to divide fractions. Sometimes students take the reciprocal of the first fraction, the one that's being divided, or even the reciprocal of both fractions. But you only want to take the reciprocal of the second fraction, the one you're dividing by. Okay, now that our problem has been changed to multiplication, it's easy. Just multiply the tops. 3 times 7 equals 21. And multiply the bottoms. 4 times 2 equals 8. And we have the answer to our fraction division problem. So 3/4 divided by 2/7 is 21/8. So that's pretty easy, but let's try one more example. Let's try 15/16 divided by 9/22. Again, the first thing we want to do is rewrite our problem. We'll change the divided by 9/22 into times 22/9. Now all we have to do is multiply. But since these numbers are kind of big, I'm going to use my calculator to help. Let's see here. So we have, all right. On the top, we have 15 times 22 equals 330. And on the bottom, we have 16 times 9 equals 144. So the answer to our division problem.
Does anyone notice something here? Here, what could he have done first? Very good. Eric is correct. He should have cross-canceled right here, right? And in cross-canceling right there, you would be able to get it in simplified form to begin with. All right, starting up again.
problem is 330 over 144. Of course, that could be simplified for your final answer on the test, but we cover simplifying fractions in another video. All right, that's how you divide fractions. You just multiply by the reciprocal and you have your answer. But there's one more thing I want to show you. You already know that the line between the top and bottom number of a fraction is just another form of the division symbol. Well, that means you'll sometimes see fraction division problems written like this. This shows the top fraction, 2 over 3, being divided by the bottom fraction, 4 over 5. It's really just that we have a fraction made up from other fractions. The top number is a fraction, and the bottom number is a fraction. It just looks a little confusing because we have all these fraction lines here. But we can make it look a lot better. Let's rewrite this as a multiplication problem by taking the reciprocal of the bottom number, the fraction that we're dividing by, and multiplying it by the fraction on top. There. That looks easier to do, and it's really the same problem. We just need to multiply to get the answer. So 2 times 5 equals 10, and 3 times 4 equals 12. Okay, so there you have it. What sounded really hard turns out to be as easy as flipping fractions upside down. If you can multiply fractions, then you can divide fractions too. Don't forget to practice what you've learned.
All right, moving forward. So let's try a couple of these problems. All right. So remember, the very first step for any sort of division is we're going to take the second one, flip it over, and change it to a multiplication problem. So I have 2 over 5. I'm going to copy that straight down, just the way it looks.
And then you're going to switch.
Change this to multiplication, and then the reciprocal of 1/8 is just 8 over 1. At this point, I'm going to deal with it just like a multiplication problem. I'm going to look to see if I can cross cancel. And if I can't, I'm going to multiply. So, 2 times 8, 16. 5 times 1 is 5. I have an improper. So, 5 goes into 16 3 times with 1 left over. 1, 2. This next one, again, copy down the first one. Change it to multiplication. And then flip the second one over. So notice with this one, I can go ahead and cancel here. So I can cancel 1 and 1. So 1 times 23. 23 over 7. And then I can simplify this. 27 goes into 23 3 times with 2 left over. 2 sevens. One thing you can do if you're having trouble simplifying these improper fractions is just take the top number and divide it by the bottom. Right? That'll give you the whole number up front, and then multiply what number you get by the bottom one, and then subtract it from here. This last one, remember we're going to change this to 8 over 1. Copy down the first one, change it to multiplication, and then flip over the second one, 1 over 8. So from here, I'm going to simplify a 1 and a 4. And then multiply the tops together and multiply the bottoms. So 1 times 1, 1. 3 times 4, 12. There's my answer. Not bad. Light work. So try these ones on. All right. So remember, we're going to
Be quiet, please.
write this down. The first one, just as we see it. Change it to multiplication. Take the second one, flip it over, and then we multiply. Since there's nothing I can cancel, I'm going to multiply the tops together and then the bottoms. 1 times 8 is 8. 3 times 1 is 3. 8 goes in, or 3 goes into 8 2 times. 2 left over. 8 and 2/3. Next, copy the first one down. 4 over 15. Change to multiplication. Flip the second one over. 9 over 1. And then, now here, I can go ahead and cancel. I can make a 3 out of both of those. 9 divided by 3 is 3. 15 divided by 3 is 5. And then I'm going to go ahead and multiply across. 4 times 3 is 12. 5 times 1 is 5. 5 goes into 12. 2 times, with 2 left over, I put that 2 over 5. So that's 2 and 2/5. And the last one on this page. Copy down this first one. 2/3. Change to multiplication. Remember, that's 10 over 1. So I'm going to flip that over.
1 over 10.
And then I'm going to go ahead and divide top and bottom by 2 here. And then multiply across. 1 times 1 is 1. 3 times 5, 15.